morning, children. Today we are going to prove a very famous theorem, Pythagoras Theorem, using similarity of triangles. You are very familiar with the Pythagoras Theorem application as in a right triangle, the square of hypotenuse is equal to sum of the squares of the other two sides. You are applying this theorem from class 6 or 7 onwards, but what is the proof of this theorem using similarity? That is what we are going to do in today's class. Before proving Pythagoras theorem, let me explain a very important theorem which can be used to prove Pythagoras theorem. Let triangle ABC be a right triangle. Angle B is 90 degree. Through angle B, let BD be a perpendicular. That is, let BD perpendicular to AC. That is, you have taken a right triangle, you have taken a perpendicular through the right angle. Now, what will happen to the two triangles on either side of the perpendicular? That is what we are going to prove. By the known similarity in triangle ADB and ABC, can you prove them as similar? Triangle ADB and ABC. Angle 1 is equal to angle B is equal to 90 degree and angle A equal to angle A common. Therefore, triangle ADB similar to triangle ABC by AA similarity. That means you are proving the small triangle ADB similar to the big triangle ABC. Similarly, can we prove CDB? Similarly, in triangles CDB, CBA, I am taking the triangles in this order to make you sure that which is the common angle and which is the 90 degree. The common angle in the beginning and the 90 degree in the center position. Angle C is equal to angle C common. Again, angle 2 is equal to angle B is equal to 90 degree. Therefore, triangle CDB similar to triangle CBA also by AA similarity. By these two results, ADB similar to ABC and CDB similar to CBA, you understood that the triangles, small two triangles are similar to each other. But how do you arrange them, or what is the position of the angles in the similar triangles? Let us arrange it. Triangle ADB similar to triangle ABC as equation number 1. You have proved triangle CDB similar to triangle CBA. Triangle CDB similar to triangle CBA. In order to compare the similarity of these two triangles and to position the angles properly, we need to arrange this triangle CBA also as ABC. At the same time, the angle corresponds to triangle CDB also should be changed. That is, ABC is the order, BDC is the order. Therefore, triangle BDC similar to triangle ABC, equation number 2. From here, 1 and 2, you understood that triangle ADB similar to triangle BDC. That is, angle A is corresponding with angle B, then angle D corresponds with angle D because both are 90 degree, and angle B corresponds with angle C. See the position, angle B corresponds with angle C. That is, the theorem states that if a perpendicular is drawn through the right angle of a triangle, if a perpendicular is drawn through the right angle of a right triangle, then triangles on either side of the perpendicular, triangles on either side of the perpendicular are similar to each other, they are similar to each other and to the whole triangle. Pythagoras Theorem. In a right triangle, the square of hypotenuse is equal to the sum of the squares of the other two sides. You need to study the statement also, because for the exam they may ask state and prove Pythagoras Theorem. In a right triangle, so the figure given, triangle ABC is right angled at B. You may also draw in an upside down position, but this will be familiar to you as the previous explanation. In a right triangle, the square of hypotenuse, if angle B is 90 degree, AC is the hypotenuse. That means the meaning of hypotenuse is the side opposite to the right angle. The square of the hypotenuse is equal to sum of the squares of the other two sides. So given triangle ABC, right angled at B, right angled at B. What is to prove is square of hypotenuse, that is AC square, is equal to sum of the squares of the other two sides. Other two sides are AB and BC, that is square of other two sides means AB square plus BC square. Now, the theorem will be proved through similarity. So, as in the previous explanation, the construction is draw BD perpendicular to AC. Construction draw BD perpendicular AC. The concept here is to prove triangle ADB similar to ABC and take the proportional sides. Similarly, CDB similar to CBA and take the proportional sides. You may use the other theorem too, but then you have to write the statement in full. I will be proving it by taking the triangles separately. Proof. In triangles ADB, ABC, the order, if you maintain like this, angle A is common and angle 1 is equal to angle B 90 degree, can be easily remembered. Angle A equal to angle A common. Angle B is equal to angle 1 is equal to 90 degree. Therefore, triangle ADB similar to triangle ABC by AA similarity, the proportional sides AD by AB is equal to DB by BC, we are not taking, AB by AC. So that by cross multiplication, AB square is equal to AD into AC, mark it as equation number 1. Similarly, the second part, similarly, in triangles CDB, CBA, angle C is equal to angle C common, angle 2 is equal to angle B is equal to 90 degree. Therefore, CDB, triangle CDB, similar to triangle CBA by AA similarity, proportional sides CD by CB, CD by CB is equal to CB by CA, or you can arrange as BC square is equal to AC into CD, equation number 2. Now, equation number 1, AB square is equal to AD into AC. Equation number 2, BC square is equal to AC into AD, and you need to prove what is the total of AB square plus BC square. So, by adding AB square plus BC square is the same as AD into AC plus AC into CD. You can see AC as common, which is the same as AC into AD plus CD. In the figure, AD plus CD is giving you again AC, which is equal to AC into AC or AC square. Thus, Pythagoras theorem is proved by using similarity of triangles. Converse of Pythagoras theorem. This also may be asked as state and prove the converse of Pythagoras theorem. Statement need to be studied. Statement is, in a triangle, you cannot mention it as a right triangle. In a triangle, if the square of one side, again we are not using the word hypotenuse, if the square of one side is equal to the sum of the squares of the other two sides, then the angle opposite to the first side, that means the side we have considered here, is a right angle. So the statement is, in a triangle, if the square of one side is equal to sum of the squares of the other two sides, then the angle opposite to the first side is a right angle. So the given figure is just a triangle ABC, and where the square of one side, the given condition will be given triangle ABC in which AC square is equal to AB square plus BC square. So the first side what we have taken here is AC. Opposite to AC is angle B. So what is to prove is angle B is equal to 90 degree. Here the construction plays a very important role, because we can construct a triangle with the measure of BC and AB at the same time with the included angle as 90 degree. That is, the construction is construct a right triangle, not only that right triangle with a, what is a measure, with right triangle PQR with the measure of BC or AB as PQ and BC as QR. That means with the length of PQR, with the length of AB as PQ and BC as QR. Let's see how it is done. You are taking a QR line segment, construct a right triangle. With AB measure, you will take it as P. So it is a possible construction. That is, construct a right triangle PQR with AB is equal to measure of AB as PQ, measure of BC as QR, but the only difference is angle Q should be 90 degree. Now, the proof starts with this right triangle because you know how to apply Pythagoras Theorem. Proof starts as application of Pythagoras Theorem in triangle PQR. Proof: in triangle PQR, angle Q is equal to 90 degree. What will be Pythagoras theorem? Therefore, PR square is equal to PQ square plus QR square in bracket Pythagoras theorem. But what is the value of PQ? PQ is AB by construction and QR is BC by construction. So you will replace as AB square plus BC square by construction. But what is AB square plus BC square? It is AC square because it is a given condition. AC square, which is a given condition. Therefore, you got PR and AC length also as equal. Now, take both the triangles ABC and PQR. What can you derive about them? You drew AB and PQ of equal length, BC and QR of equal length, and you could prove triangle AC and PR are of equal length, which shows that both the triangles are congruent. Let's prove the triangles are congruent. In triangles ABC and PQR, AB is equal to PQ and BC is equal to QR construction, and AC equal to PR you proved. Therefore, triangle ABC congruent to triangle PQR by SSS congruence. Once the triangles are congruent by the corresponding parts of congruent triangles, in angle Q is 90, angle B is also 90 degree. Therefore, angle B is equal to angle Q is equal to 90 degree by CPCT. Hence, the proof. Exercise 6.5. Question number 1 is to check whether the given measures are the sides of a right triangle. You can prove it on your own. Question number 2. PQR is a right triangle, right angled at P, and M is a point on QR such that PM perpendicular to QR. Show that PM square is equal to QM into MR. PQR is a triangle, right angled at PQR is a triangle, right angled at P. Right angled at P, and M is a point on QR such that PM perpendicular to QR. PM perpendicular to QR. Show that PM square is equal to PM square is equal to QM into MR. QM into MR. So what is given is triangle PQR right angled at P. If you see the proof, if you see the part to be proved, PM square is equal to QM into MR, check the measures. PM square means PM into PM, QM and MR, which shows that you have to prove triangle RMP similar to triangle QMP. The proof, divide this as 1, 2, 3, 4, 5. The same proof will be repeated. Angle 1 plus angle 2 is equal to 90 degree. It is given. In triangle PMQ, angle 2 plus angle 3 plus angle 5 is equal to 180. Angle sum property, that is angle 2 plus angle 5 is equal to 90 degree. Since angle 3 is 90 degree, from 1 and 2, from equations 1 and 2, angle 1 plus angle 2 is equal to angle 2 plus angle 5, or 1 corresponds with 5. Angle 1 is equal to angle 5. In triangles RMP and QRMP and PMQ, angle 1 is equal to angle 5, proved. Angle 4 equal to angle 3 equal to 90 degree. Therefore, triangle RMP similar to, R should correspond to the letter P, M should correspond with M, and P should correspond with Q. That is triangle PMQ. The proportional sides, RM by PM, it's by AA similarity. RM by PM is the same as PM by MQ, or PM square is equal to RM into QM. You can write here proportional sides of similar triangles. Question number 3. In the figure, ABD is a triangle right angled at A and AC perpendicular BD. You have to prove AB square is equal to BC into BD, AC square is equal to BC into DC, and AD square is equal to BD into CD. It's the same proof as we have done in question number 2, and the 3 results, how you are getting is, you have to prove each small triangle similar to the big one and take the proportional sides for 2 results, and the third results as the triangles on either side of the perpendicular similar. You can try on your own. It's a similar proof. Please refer the previous part of the beginning part of the video and do it. 4th question and 5th question are like converse. ABC is an isosceles triangle right angled at C. ABC is an isosceles triangle right angled at C. Whenever they say the word right angle, hypotenuse definitely has to be the longest side, which proves that the sides can be only AC and BC as equal side. AC and BC are equal at the same time. Angle C is equal to 90 degree. What is to prove is, prove that AB square, to prove is AB square is equal to 2 times AC square. Since ACB is a right triangle, you can apply Pythagoras Theorem. Proof: in triangle ACB, hypotenuse square AB square is equal to AC square plus BC square. It is by Pythagoras Theorem. But what's the relation between AC and BC? They are equal. In the question, you have to prove it as twice AC square. So replace BC with AC. AC square plus AC square. It is already given. That is AB square is equal to 2 AC square. And question number 5 you can see as ABC is an isosceles triangle with AC and BC are equal. So the given condition is AC and BC are equal. In triangle ACB, the given condition is AC and BC are equal. If one more condition is if AB square is equal to 2AC square, what is to prove is angle C is equal to 90 degree. As the given condition says, the proof will start from there. AB square is equal to 2AC square. It's already given in the question. Split it as AC square plus AC square. Since AC and BC are equal, replace AC square plus BC square. Replace one of the AC with BC. Or since AB square is equal to AC square plus BC square. That is, AB square length is the same as AC square plus BC square. What do the converse of Pythagoras theorem say? If the square of any one side is equal to sum of the squares of other two sides, angle opposite to the first side is a right angle, which shows that angle C is equal to 90 degree. The reason is converse of Pythagoras theorem. Any one of these questions can be asked as a 2-mark question. Question number 6. Triangle ABC is an equilateral triangle of side 2A. Find each of its altitude. Triangle ABC is equilateral triangle. Each side is measuring 2A. You need to find the length of the altitude. And now, given triangle ABC is equilateral with side 2A, what is to find is the length of AD, the altitude. Before proving it, let us prove that the triangles ADB and ADC are congruent, by which we can derive a property which is useful for this proof. In triangle ADB and ADC, angle 1 is equal to angle 2 is equal to 90 degree. Then AD is equal to AD common. AB equal to AC, the sides of equilateral triangle. Therefore, triangle ADB congruent to triangle ADC by RHS congruency. From there, the length BD and DC are equal as CPCT. So, it is a property that in an equilateral triangle as well as an isosceles triangle, altitude bisects the base. For the exam, you need to write only this property because it will be a 2-mark question. We can prove it by this method, proof. You have to get the length of the altitude AD. Now, since BC is equal to 2A, the total length of BC is 2A, which shows that the DC length is half of 2A, which is equal to A, by the reason in an equilateral triangle, altitude bisects the base. You have DC length as A, AC length as 2A. You can take the triangle. In triangle ADC, angle 2 is 90 degree. Therefore, by applying Pythagoras theorem, AC square is equal to AD square plus DC square. AC square means 2A the whole square is equal to AD square plus A square. 4A square is equal to AD square plus A square. or AD square is equal to 3A square, or the length of the altitude is root of 3A square, which is equal to root 3A units. That is, the altitude is root 3A units if each side measures 2A units. Question number 7. Prove that sum of the squares of the sides of a rhombus is equal to sum of the squares of its diagonals. A very important 3-mark question. Prove that sum of the squares of the sides of a rhombus. What's the peculiarity of a rhombus is all the sides are equal as well as the diagonals bisect at right angles. That is why this question have come in this exercise. Sum of the squares of the diagonals. Let's draw the figure as normally we draw the rhombus in this particular shape to make it very clear that the diagonals bisect at right angles. So given ABCD is a rhombus, what is to prove is the sum of the squares of the sides. The sides are AB, BC, CD and DA. What is the sum of the squares? That is AB square plus BC square plus CD square plus DA square is equal to sum of the squares of the diagonals. Diagonals are AC and BD. That is AC square plus BD square. What is the peculiarity of the diagonals of a rhombus? Diagonals bisect at right angles. In a rhombus, diagonals bisect at right angles. So you can prefer any one triangle here. In triangle BOC, BC square is equal to OB square plus OC square. You can write it as Pythagoras Theorem. Now, the diagonals bisect. What is the meaning of the word bisect is the full length AC is cut into two equal parts at the point O, or AO and OC are equal, BO and OD are also equal, which proves that OC is half of the total length AC and OB is half of the total length BD, because we need AC square and BD square in the proof. You can write here, since diagonals bisect. BC square is equal to AC square by 4 plus BD square by 4. The common LCM of 4 will get cross multiplied. 4 BC square is equal to AC square plus BD square. Now, what is the peculiarity of a rhombus? All sides are equal. The meaning of 4 BC square is each side BC, CD, DA and AB are equal, which proves that 4 BC square can very well be arranged as, therefore, AB square plus BC square plus CD square plus DA square is equal to AC square plus BD square. If you want, you can give a reason. In a rhombus, all sides are equal. Sides are equal. This is a very important 3-mark question.